Hi students, welcome to Vedantu NEET English. I'm 𝐂𝐡𝐞𝐤 𝐎𝐿, your chemistry master teacher. So how are you all, everybody? Am I visible? Am I audible to all of you? Everybody, if I'm visible and audible, then let me know in the chat box. And today we are going to do day 2 of organic chemistry, where we are going to do previous year questions, top 50 previous year questions from organic chemistry, right? So these are the kind of questions that are repeatedly asked in your NEET exam, right? And for sure they will be asked in next year, that is NEET 2025 as well, right? So this is the best way to understand that whether you are like where actually you lie in organic chemistry, because guys, you still have 4 months to improve yourself. So I would really suggest you to watch this lecture throughout and analyze yourself that what are the problems that you're basically facing in organic chemistry, because predictable questions are asked here every year, right? You can easily predict the kind of questions they can ask, right? So I'm going to start the session, right? Okay, so let us start the session without wasting any time. But I want all of you to answer in the comments, in the chat box also, because I don't want this to be a monotonous thing. I want that you guys also answer, right? Solve the questions yourself, right? That will help you also, and it will make the class fun. Okay, chalo. Now let us start the class. The first question on your screen is, the first question, guys, on your screen is, the alkane that gives only one monochloro product on chlorination with Cl2 in presence of, every question is different here. All the questions, they are not linked to each other. They are not like you will see repeatedly, ma'am, you are telling us the same question only. Every single question that I have picked up is a different question. Okay, that means 50 topics. So you are doing 50 top topics you are going to do today, right? So this is basically, we are talking about chlorination with Cl2 in presence of diffuse sunlight. That means Cl2 in presence of H mu, right? That means here we are talking about Cl2 in presence of H mu. This is what we are talking about, right? Now here it is, alkene that gives only one monochloro compound. That means you have to see the hydrogens here, right? Are all the hydrogen of same type? That means there are 3 type of hydrogens: primary, secondary, tertiary. You have to see, are all the hydrogens of same type or different type? If all the hydrogens are of same type, then the answer will be that particular compound is going to give us monochloro product, because basically this is a reagent which gives you substitution reaction. Okay, this is a reagent which gives substitution reaction. It is going to substitute hydrogen, right? And here about this particular reagent, right, I'll tell you that if you talk about this question here, what is firstly isopentane? Isopentane is, iso means on one carbon you should have 2 methyl groups. And now complete the other carbons here. So it would be 1, 2, 3, 4 and 5. It is going to be this thing. That is CH, this is 2, this is CH. What about 2,2-dimethyl butane, guys? 2,2-dimethyl. 2,2-dimethyl butane. That means firstly write down butane here. So it will be 1, 2, 3, 4. And this is 2,2-dimethyl. That means on second position you have dimethyl, and on one more position, that means second, you have 2 methyls here. So this is going to be your answer here, CH2, CH3, right? Okay. 2,2-dimethyl butane, 2,2-butane, 2,2-dimethyl. Okay. Neopentane. If you talk about neopentane, here basically you will have this thing in carbon when you have 3 methyl groups attached. That is called neo, right? So here it will be CH3, CH3, CH3. Then complete the number of carbons here. You have 5 carbons, so it are totally 1, 2, 3, 1, 2, 3, 4 carbons. So one more carbon will be attached here. Last is N-pentane. N-pentane means normal chain. So it is going to be 1, 2, 3, 4, 5. Now guys, tell me where you can see that all the hydrogen atoms are of same type. If you talk about the first compound here, that is very good. Third, very good. Third is the correct answer. Absolutely right. Now if you see that over here, this is a 1 degree hydrogen. This is a this hydrogen, they both are of same type. But this hydrogen, if you see this particular hydrogen, this hydrogen over here, this hydrogen is connected to that carbon which is further connected to 3 carbon. So it is a 3-degree carbon. It is 3 degree, right? It is 1 degree. It is also 1 degree. What about this one? This hydrogen is connected to that carbon which is further connected to 2 carbon. So it is 2 degree. This is also 1 degree. This hydrogen is also 1 degree. So basically you have 3 types of hydrogen here. Definitely it is not going to give you monochloro compound, right? It can substitute hydrogen over here also, here also, here also. So different kind of products will be formed, right? Okay. Now, next is, if you talk about 2,2-dimethylbutane, again you have these three of same type, right? Then this one is of different type. Then this hydrogen is of different type, right? All these hydrogen after the substitution will give you different products, right? Okay, but what about neopentane? In neopentane, as you can see, this hydrogen, this hydrogen, this hydrogen, this hydrogen, all are same type. If you replace hydrogen here, you replace hydrogen here, you replace hydrogen here, you replace hydrogen here, all is going to, everything is going to give you the same compound, right? That means monochloro product will be, only one monochloro product will be formed here. So answer is going to be C is the correct answer, right? Okay, understood? Chalo. Next question on your screen, guys. Next question on your screen. Hydrocarbons A reacts with bromine by substitution to form alkyl bromide, right? What they are telling, right? Very important question, right? First is hydrocarbon A. There is some hydrocarbon A. They are saying on reacts with bromine by substitution to form, by substitution it is going to form alkyl bromide. Okay, some RBr it is forming, right? Now, which by Wood's reaction, I am assuming this A to be, let it be A only, right? This is RBr it is forming, which by Wood's reaction with adding sodium and dry ether, right? It is going to double up. We know that Wood's reaction means R will become RR, right? So here R will become RR. Now they are telling that which by further Wood's reaction is converted to a gaseous hydrocarbon. Gaseous hydrocarbon means that is having less number of carbon. That is gaseous hydrocarbon. Gaseous hydrocarbon containing less than 4 carbons. Less than 4 carbons. Now guys, I told you that in Wood's reaction, even number of carbons are formed. Symmetrical carbons are formed. So if you talk about less than 4, 4 it cannot form. 3 odd number it will not form. 2 is the possibility. That means, and 1 also it cannot form, right? Okay, because 1 so it's not possible only in Wood's reaction. That means ethane is the only possibility. So this RR will be CH3, right? By this I can say that means this RBr will be, this is your R part, right? So this will be CH3Br, right? Now, here, ma'am, from which compound this is formed? From which compound? If you talk about methane, right, you do the substitution in presence of sunlight, then one hydrogen is replaced by the bromine. So answer they are asking you A. A is going to be, guys, everybody, 3 is the correct form. That is, methane is going to be A. They could have also asked you what is B, what is C, what is T, right? These kind of sequence questions are also asked in organic chemistry. Okay, got it? Yes. A is CH4, methane. After the substitution in presence of sunlight, hydrogen is replaced by bromine. After that, we know that if this is CH3Br, after that you do the Wood's reaction, you will form CH3. The important point here was to understand what is this RR. After that, you go back, you go reverse to this reaction and you will get your answer. Okay? Yes, bacha, understood everybody? Yes. Now, next question on your screen, you have liquid hydrocarbons. They are saying liquid hydrocarbons can be converted into a mixture of gaseous hydrocarbons. Liquid hydrocarbons into gaseous hydrocarbon. Basically, here they are talking about that you have large number, the hydrocarbon having like maybe 20, maybe 18 number of carbons, right, which has more molecular weight, that kind of hydrocarbon is converted into gaseous. See, liquid hydrocarbon has more molecular weight, gaseous has less molecular weight. So that means you are breaking something big into something small. By which process? By oxidation, by cracking, by distillation under reduced pressure, by hydrolysis. So this is done by cracking, right? There is a big molecule, we crack this and convert it into small hydrocarbons. So right, so answer is B, that is cracking is the correct answer. Okay, B, cracking is the correct answer here. Okay. Next question on your screen, the reaction of ethyl magnesium. Guys, Grignard reagent is one of the most, that's why I am telling you that I have picked up the most important questions here, right? So, Grignard reagent is most important, beta, very important. It's like very important reaction, right? They frequently ask Grignard reagent, at least in every single paper, you will see 1 to 2 questions of Grignard reagent for sure. Right. So, the reaction of ethyl magnesium bromide with water would give. Now, firstly, what is, ma'am, this Grignard reagent? Grignard reagent is an organometallic compound. That means carbon is attached to a metal, right? This is Grignard reagent. Now, in Grignard reagent, this is because metal is electropositive. That's why this will be partially positive. This is partially negative. Now, in Grignard reagent, 2 kind of reactions are very famous, right? Second kind of reaction, I have also picked up a question regarding that. First kind of reaction is that Grignard reagent is very sensitive towards proton donors, right? If someone is giving them proton, they will easily be converted into alkanes, right? So, if you talk about water, right, water is a proton donor, right? It is a proton source. Whenever they will see any proton source, they will go crazy in love, right, of a proton source. They will leave everything, right? This R is like crazy for proton, right? If he gets proton anywhere, like anywhere, just water is just like a source of proton, right? So other source of protons are like alkyne is also a source of proton. They can also ask you the same question in NEET 2025, asking you that here you have alkyne, here you have another proton source, some acid you have, that is also proton source. So basically what it is going to give you, it is going to take the proton and become RH, right, and it is going to release MgXH, that will be released. That means alkane is formed after that, right? It is very reactive. That is why whenever in the formation of Grignard reagent, we use dry ether. Why dry ether? Because it is very reactive towards moisture. This question also can be asked in assertion reasoning form. That's why I'm not only just teaching you the question, I'm also teaching you the other question that can be asked from this particular question. Okay, right? Okay, yes. So here we have, if you talk about ethyl magnesium bromide, that means CH3 MgBr. Now guys, tell me what kind of alkane it is going to give you. Very good. B, ethyl, B or A? What kind of alkene it is going to give you? Alkane will be CH3 and H, that means CH4, that means, not CH3, this is ethyl magnesium, na? So this will be, ethyl magnesium will be, this is C2H5, right? So it is going to give you C2H6, C2H6, that is ethane. Ethane it is going to give you. So answer is going to be A, ethane is the correct answer. Got it? Yes, very good, very good. Next question on your screen we have, which one of the following, okay guys, let us see who can answer first. Okay, let us see that. Which one of the following reaction is expected to readily give hydrocarbon product in good yield? In good yield they are talking about. That means the side product should be vaporizable. Right. So if you talk about these things here, first thing is they are talking about expect to give a hydrocarbon product in good yield. Firstly, this is not going to give you a hydrocarbon product. This is also not going to give you hydrocarbon product. This will replace the Br here, right? So it is going to give alkane, it is going to give RBr. This is also not going to give hydrocarbon. So hydrocarbon is only possible in A. See, it is going to substitute it. It is going to give you CH3, CH2, Cl substitution reaction will occur here, right? This is basically you have Cl, this is ethanol, right? And here it is going to just substitute. This is ethanol, right? So it is going to just substitute. Also, it is not going to give you alkane. What about this? This is Hunsdiecker reaction. This is Hunsdiecker reaction. This is Hunsdiecker reaction, right? A naming reaction. Now see in the option this is given, but maybe in next year they will ask you directly this question only, right? This is how previous year questions are repeated, right? So is this Hunsdiecker reaction where RBr will be formed, okay? So only in first question, can you name me what is the naming reaction of A? What is the name of this A option? What is the name? The name is, yes, very good. The name is Kolb's electrolysis. Kolb's electrolysis. So in Kolb's electrolysis, you are going to get R, right? Okay. This is what you are going to get in Kolb's electrolysis, right? So it is going to give you, A is going to give you the correct answer, right? Okay. A will be the correct answer. Very good. A is the correct answer. Very good. Very good. 𝐂𝐡𝐞𝐤 𝐏𝐥𝐚𝐲𝐥𝐢𝐬𝐭𝐬 Sushmita, very good. Yes, very good, Siddharth. Next is in the free radical chlorination. Now we are talking about free radical chlorination of methane. The chain initiation step involves the following. Very, very simple question, guys. Very, very simple question. Chain initiation step involves the following. Chlorine free radical, hydrogen chloride, methyl radical, chloromethyl radical. If you talk about, they are saying that chain CH4 you have, right? Which free radical will be formed? Which free radical will be formed? Firstly, chlorine will give you the free radical. After that, methane will have the free radical. So answer is going to be chlorine free radical. Usually students get confused in methyl free radical and chlorine free radical. So both are formed, but in the first step, chlorine free radical is formed by homolytic cleavage of this Cl2 here in the presence of sunlight. That is the initiation step, right? Next question, guys. On your screen we have an alkene on ozonolysis. Again, as I told you that Grignard reagent and ozonolysis are one of the most favorite questions of NEET. One of the most favorite questions. And both of these questions are very, very simple, very, very simple, right? If you have to give the priority, then ozonolysis will be on the top, right? It's a very, very important reaction, right? So, an alkene on ozonolysis, see if some simple ozonolysis is given to you, that means you're talking about reductive ozonolysis, right? Okay. So, firstly, all the students who are here for revision as well. So, guys, a simple thing is that you will have alkene. You just break this double bond, apply double bond here, double bond over here. That's it. This is simple ozonolysis. That's it, right? This is ozonolysis, right? Okay. So, this is how you're going to answer it. Alkene gives methanol is one of the product. Methanol means it is going to give you CH. Methanol means C double bond OH. This kind of product it should give you, right? So let me see here. Here it should be a double bond over here, right? Wait a minute. I think that is not mentioned here. Let me just correct it, right? Okay. Yes. Here the double bond is over here, right? And here the double bond is over here. Here the double bond is over here. Now you tell me which is going to give you methanol. For methanol, very good, very good. Shabash, shabash, shabash. B is the correct answer. Here what will happen? Here what will happen? This bond will break. This bond will break. Here you will have double bond O. Here also you will have double bond O. So it is going to give you this thing. It is going to give you this thing. That is, this is CH2, C double bond OH, and this is going to be HC double bond OH. A methanol is formed as one of the products. So answer B is the correct answer, right? Okay. Okay. Next question is, we have an alkene A on reaction with, again, ozonolysis, right? With, see, first kind of question is this kind of question they can ask you from ozonolysis. Second is this kind, right? So here it is an alkene A on reaction with O3ZnH2. That means they are talking about reductive ozonolysis, right? Okay. Now, gives a propanone and ethanol. Firstly, to draw these two structures here, right? Okay. Firstly, let us draw these structures here. What is it? Propanone and ethanol. So I'm going to draw propanone here. Propanone means 1, 2, 3. Propanone means double bond over here. This is CH3. This is CH3. Other is ethanol. Ethanol is CH3, C double bond O and H. Now, ma'am, I have to tell that which alkene it will give, right? Which alkene will give these two things, right? So what you do, just rearrange this thing like that. This is H na, so just draw it like this. Double bond O and this is H. Same thing I have drawn, right? The way of drawing is different. Here instead of this, write it like this. Okay, instead of this, write it like this. C double bond O. This is CH3. This is CH3, right? Now, what will happen? What I'm going to do? Just replace this double bond O, double bond O, double bond O and join these two together. This is the alkene that is going to form these two aldehyde or ketone, right? Okay. So here addition of HCl to alkene, right? This is the alkene. Okay, got it now? This is going to be that alkene. Very good. You guys have already answered. Very good. Now after that they are saying that addition of HCl to this alkene. You are adding HCl to this alkene. That means now the second concept of this reaction is Markovnikov addition. When you don't have peroxide, even HCl, so you have peroxide, even then it will be Markovnikov addition only. In HBr, if you have peroxide, then it is going to change to anti-Markovnikov, right? So here Markovnikov addition will happen. That means the negative part will go to less number of hydrogens, okay? Negative part will go to less number of hydrogens. So it is going to be CCH3. Less number of hydrogens are over here. So it will be, here you will have Cl, right? And here it will be CH2CH3, right? Now, addition of HCl to alkene gives B as a major product. Structure of B, they are asking you. To the carbon, you have 2 CH3 and 1 Cl should also be there, right? Then you have CH2Cl3. So, answer will be C is the correct answer, right? Okay. Okay, guys. Okay, so C is going to be the correct answer here. Got it, everyone? Let me see how many of you have answered C. Nobody. Why you guys have not answered C? Why B you have answered? This is the double bond, right? It is going to break the pi bond and the negative part is going to the less number of hydrogens. That means Markovnikov rule will be followed here. Two very important concepts we are applying here. First is ozonolysis. Second is Markovnikov addition of first, right? Okay, chalo. Next we have in the reaction with HCl. Now you have the reaction with HCl. An alkene reacts in accordance with Markovnikov. Now they are saying that an alkene, in the addition of HCl, alkene reacts in accordance with Markovnikov rule to give product 1-chloro-1-methyl cyclohexane. The possible alkene is. Firstly, let us draw this product, that is 1-chloro-1-methyl cyclohexane. Cyclohexane means this thing, right? Okay, cyclohexane means this thing. 1-chloro-1-methyl, let us draw it here, right? So it is 1-chloro-1-methyl. They are saying that this is formed by some HCl Markovnikov addition. You have to tell which alkene could have formed this. Options are given this, this and this. Here, this is the double bond over here, right? Okay, here double bond is over here, here double bond is over here. So guys, if you talk about the first one, here, right, after Markovnikov addition, we know that the pi bond will break, right? After Markovnikov addition, the pi bond will break, right? And what will happen? The pi bond is going to break and what is going to happen? Yes, everyone. The pi bond will break and Cl, that means negative, this is positive. Negative part will go to less number of hydrogens, that means over here. and positive to more number of hydrogen. That means this will be CH3. And in the hurry, what students will do, they will just mark it A is the correct answer, ma'am. Right? Array, just see this option, na, A and B. So B can also be the right answer here. Right? Definitely it is going to give you this product. What about this thing? What about this B? What about this B? It is C, this is CH3, this is double bond. Here also, when you are adding, when you are doing the Markovnikov addition, right? When you are doing the Markovnikov addition, we know that this pi bond will break, this pi bond will break, right? When this pi bond will break, then can we say that when this pi bond will break, can you tell me where you have less number of hydrogens? Less number of hydrogens are on this carbon, So Cl will be attached here and hydrogen will be attached here. So answer will be same this. So that means B is also going to give you the same answer. That means C is the correct answer. That means both A and B are going to give you the answer that they are asking for after applying Markovnikov addition. Right, guys? Clear? C is the correct answer. Methyl cyclohexane. Very good. Right? Chloromethyl. Right? Okay. Next is on your screen the reaction of, now beta, the reaction they are talking about, the reaction of this with HBr will produce, right? So as you can see, this is a very important reaction, right? Okay, very important question. This is C6H5. Then you have C6H5 means this thing, right? Then you have CH double bond, CH double bond, CH3, right? Okay. Now, here, can you see one thing, everybody? Yes, Shushmita, you are definitely visible to me. Yes, I can see your messages. Right. So, here HBr will produce. Basically, here they have not given any peroxide. So, that means Markovnikov rule we will apply here. Markovnikov rule means this pi bond will break and hydrogens, if you talk about, this is also CH, this is also CH, right? So, ma'am, here where you will apply the negative part. This is positive, this is negative. Ma'am, Br will be applied on which side? Both are having the same. Now, this is interesting. We were telling that less number of hydrogen, the negative part will go to the less number of hydrogens, right? But here, as you can see, both are having same number of hydrogens. Then what will be the correct answer? Guys, basically Markovnikov rule is like carbocation. Firstly, there is carbocation formation. After that, you have the attachment of negative part on that carbocation. You have to tell me which carbocation will be more stable, this one or this one. Definitely because of resonance, this one will be more stable. So we will not pick this, we will instead pick this one. That is why Cl negative will be attached to this side and H2 to this side. So this is going to be the correct answer. That is C6H5CH, this is Br. Here they are talking about Br, right? So here it will be Br, right? CH2, CH3. So D is going to be the correct answer, right? Okay, very good. D for dosa, ma'am, is the correct answer. Next we have, I think that is very less visible to you. So I'll just write it down with pen, right? So basically here they are telling you that you have H positive and heat. Then after that you get a major product and a minor product, right? Major is A, minor is B, right? Minor is B. After that, you pick out this A, right? Then HBr, you give HBr over here in dark, right? In absence of peroxide, no peroxide is here, you have C plus D. Now, C is the major product. C is the major product and D is the minor product. Okay, just write it here. C is the major product, right? And D is the minor product. I think now you are able to see me. If even now is this not visible, then I'll just write it again, right? Okay. So here it is giving you H positive with heat. A and B are giving the major. This is major, right? And this is minor, right? After that, this major product with HBr in dark, in dark. In absence of peroxide, it is going to give you C and D. C is the major product, D is the minor product. Okay, so now you have to tell me which is the correct answer. Right? Okay, yes. Now let us see this here. Let us see this here, guys. Now they are telling this is some product which is alcohol, right? Okay. H positive and heat, what it is going to give you? H positive and you heat it, it is going to give you an alkene. Right, so two kind of alkenes will be produced. First, I'm just going to write this here. This is CH3, CH, CH, CH3. This is CH, CH3, CH, CH3, and this is OH. Right. First thing is they are telling you that after H positive and heat, what it is going to give you. So after H positive and heat, it is going to take out, this is H and this is also H over here. There are two, this is basically alpha, there are two beta hydrogens that you have, right? Okay, so now guys, what will happen? Two things are possible. OH will be eliminated from this side or this side or this side, right? So that means two things are possible here. Two things are possible. One is CH3, CCH3. If beta hydrogen is eliminated from this side, then double bond will shift here and you will have double bond. This is CH, CH3. But if beta hydrogen is shifted from this side, then double bond will shift here. So then the answer will be CH3, C, CH3, CH. This is CH double bond CH2. Right? Now, can you tell me which is the minor and which is the major product? Minor product is, see, major product is Sedzev product. Sedzev product means which is more highly substituted, alkyl substituted, that alkene is going to be the major product. This is based on hyperconjugation. More is the hyperconjugation structure, more is the alkene. So you can just directly apply this rule that in that double bond, here you have only one alkyl group. But in this double bond, you have 1, 2, 3 alkyl groups you have. That means this is going to be the major product. This is going to be the minor product. So here they were telling that A is the major product. That means this is going to be A and this is going to be B. After that, they are telling that this A, right? If you write this A over here, this will be CH3, C, CH3, right? Double bond, CH, CH3. Now they are saying that in the question, beta, they are saying that in this A product, you add HBr in dark. Okay, in this A part, in this major part, I am going to add HBr in dark in absence of peroxide. That means I am going to follow Markovnikov rule, right? Okay, very good. A is the first one. Very good, Sukhmeet. Very good. Very good. Now here you have HBr. We are going to follow Markovnikov addition and anti-Markovnikov addition. Guys, listen to this side. Two products will be formed. First is Markovnikov, second is anti-Markovnikov. We know that when we have there is no peroxide, then the major product is Markovnikov product. But definitely two products we are going to make. We only consider major as the one. But here they are asking about both, right? So here it will be Br negative. The major product will be that Br2 less number of hydrogen. Less number of hydrogens are present here. So here you have Br. This is CH2. This is CH3. Right? So this is going to be C, that is the major product, right? And what about the next one? If you talk about the minor will be, which follows anti-Markovnikov rule, this will be CH3, this is CH, more number of hydrogen, that means Br2 more number of hydrogen, so this is H and this is CH3. This is the minor product, that is D. So I am saying this is the minor product, this is the major product. And what they are asking in the question, they are asking you about the A and C. That means this A and this C they are asking about. This A and this C they are asking about. So what is A, guys? What is A? A we have formed to be. A is CH3C double bond CHC3 CH3 double bond. This is A. Okay, this is A. So this is eliminated, right? Okay. This is also A, right? This is not A, right? So either answer can be B or this. Now, following the Markovnikov rule, this is what we know is our C, right? This is our C. Negative part on less number of hydrogens, right? So that means this is A and this is C that we have concluded. So answer is going to be C is the correct answer. No worries, no worries. Okay, yes. Previous year questions these are only your previous year questions. Okay, I have picked up all the previous year questions only, right? Okay, now is that clear to everybody? So C is going to be the correct answer. Okay, wait a minute. Why B? Why B? HBr in absence of peroxide they are telling na. In absence of peroxide, you have negative part to less number of hydrogen, isn't it? HBr in absence of peroxide, that means you are following Markovnikov rule. So negative part to less number of hydrogens. Negative part to less number of hydrogens will be present here. So answer should be this one. है ना? Answer should be C, isn't it? Why, Roshni? Why are you saying the answer to be B? According to me, the answer should be C only. HBr in dark. You have A, and here A means absence of peroxide is Markovnikov rule. That means negative part to less number of hydrogen. So less number of hydrogen I can see over here, right? So answer should not be this one B. Answer should be C. Okay? Got it? Chalo. Ha. Answer should be C. This is the minor is this one. This is the major. So this is C, this is D. Okay? This is A and this is B. So answer should be C, not A. I think you have cheated. Huh? Cheaters? You have seen the answer and B, ma'am. Beta, sometimes typing mistake happens, but you have to use your own brain as well. Right? Okay? How come both are same, beta? This is Br over here. This is Br on this side. How they are same? Chemistry. Where is the chemistry? This is Br over this carbon. This is Br over this carbon. Where is your specs? Chalo, ma'am is not wearing specs. You are wearing specs, na? So why doing these mistakes? Acha. Options are not same. Options are not same. Not same. Acha. Which of the following with molecular formula C5H10 yields acetone on ozonolysis? Right, acetone means you have CH3, C double bond O, CH3. Now they are saying that which of the following compound with molecular formula C5H10 yields acetone on ozonolysis, right? So you have to yield acetone over here on ozonolysis, right? C5H10 it is, right? C5H10 it is. The question is this thing. So C5H10 it should give you this particular thing, right? So if I say this is CH3 here, this is CH3 here, right? Then it should be a double bond. Now if you want to complete 5 here, so it should be like this, है ना? I just want acetone, na, which is going to give one of the product as acetone. So this will be CH2. Understood now what I did? I just rearranged this thing, that is C double bond O. This is CH3. This is CH3, right? Instead of double bond, I am going to complete the carbons here. They are saying that it is C5. So C5 is possible. 2 more carbons I need. Then complete the hydrogens here. It will be H here. 3, 4, 5, 6, 7, 8, 9, 10. C5H10 it is. So it is going to give you on ozonolysis, it is going to give you, break this double bond, it will be C double bond O, CH3, CH3, and here it is CH3, CH double bond OH, right? That means ethanol will be formed here, right? So answer will be 1, 2, 3, 4, that is 2 methyl 2 butene, right? So answer will be D is the correct answer, okay? D is the correct answer, right? Okay. Chalo. Next is, which of the following reagents converts propene to 1-propanol, right? Propene to 1-propanol. What is propene? 1, 2, 3. Propene, that means double bond over here. So it is CH2, CH, CH3, right? Which of the following reagents convert propene to 1-propanol, right? 1-propanol means I need to convert it into 1-propanol means over here you have OH, right? This is CH2, this is CH3, this is CH2. That means it should follow negative part 2. Definitely there is hydration, but here we know that negative part 2, more number of hydrogen it should be. Negative part 2, more number of hydrogen. That means anti-Markovnikov rule should be followed. Now, can you tell me, I told you 3 ways of doing the hydration. One is acidic hydration, other is hydroboration oxidation, third is oxymercuration demercuration, right? Okay. Now, tell me, which of the following is right? Very good. A, B, C, D, anti-Markovnikov rule. That is applied where? Acidic hydration, carbocation, then rearrangement. Kind of Markovnikov rule it is, right? So, no. Aqueous QH, it is the substitution reaction of replacing chlorine with OH. MgSO4, NaBH4, definitely not. It is reduction, right? B2H5, H2O2OH. So that is going to be the correct answer. So answer D is the correct answer, right? Very good. D is the correct answer. Very good. HBO, hydroboration oxidation. Very good. Next question on your screen we have. This question says that you have a compound where you are adding 2 moles of HBr and you need to tell the product here. So simple direct question they have given you. See, you just have to apply Markovnikov rule here, right? Okay. So this is the double bond, this is the double bond, this is the double bond, this is where you have NO2, here you have NO2, right? Okay. It should be placed here, okay? This should be NO2 should be placed here, right? Okay, so this is Br. Now, HBr is going to break the pi bond here, right? So first of all, if this pi bond breaks, then what I am going to have? If this pi bond breaks, then what I am going to have? If this pi bond breaks, I know that here you have less number of hydrogens. Right, if you talk about the hydrogens here you will have here you have less number of hydrogen, here you will have more number of hydrogens, right? That is why when this pi bond will break, Markovnikov rule, that means Br will be attached here and hydrogen will be attached here, so it will be this thing, right? If this bond will break, where you have less number of hydrogen, here on here you have less number of hydrogens, right? So when this bond will break, then what you are going to have? When this bond will break, Br will be present here and this is the answer that you are going to get. And this is the answer that you are going to get. That means A is the correct answer. Okay. So A is coming out to be the correct answer, right? Okay. Chalo. Now, next question is arrange the following alkanes in decreasing order. Now they are saying that arrange the following alkanes in decreasing order of their boiling point. Now one question is asked based on the boiling point. So directly you just have to remember this thing, that boiling point is directly proportional to the molecular weight. Okay, to the molecular weight, but it is inversely proportional to the branching. So more is the branching, less will be the boiling point, right? Okay, so we know that this has the maximum branching. That means in second you will have the minimum boiling point, right? Then this has even less branching, so more boiling point as compared to that. Maximum is for the first one, which is a normal chain, there is no branching. That means maximum boiling point, so it will be 2, 3, 1. 2, 3, 1. 1 should be maximum. 1 should be maximum. Then it should be 3. Then it should be 2. Right? So answer will be C is the correct answer. Right? Okay. Vanakam, beta, vanakam. So C is going to be the correct answer. That is 1, 3, 2. 1, 3, 2. That is going to be the correct answer. Right? Okay. Very good. Now, next question on your screen, beta. This is, which of the following is not the product of dehydration? Dehydration is done with the help of concentrated H2SO4. That is a very good dehydrating agent, right? Okay. P2O5 is also used sometimes, right? Okay. H3PO4 can also be used, right? So these are all your good dehydrating agents, right? Now, after dehydration, what product will be formed? That is the important thing to note down. So firstly, just draw this structure here. Just draw this structure here. OH over here. Now, beta, this is alpha, this is beta, this is beta. Again, according to Sedgwick rule, it will happen. That means that alkene will be formed which is more alkylated, which has more alkyl substituents, right? Okay. So we know that OH negative will be replaced from this side only, right? But ma'am, what about, what about this thing? So I'll just draw it like this. We know that OH negative will be replaced from this side. But ma'am, what about beta? What about hydrogen? Now, if you say that hydrogen is replaced from this side, then double bond will be present here, right? If double bond is present here, you have 1, 2, 3, 4. 4 alkyl things you have, right? Means 4 substitutions you have. But if you replace beta from this side, then this will be the double bond that you will have. Now 1, 2, 3. 3 alkyls you will have. But we need to have more the alkyl substitution, more stable will be the alkene according to Sedgwick rule. So this will be the major product, right? This will be the major product. So here the answer will be, guys, can you identify this over here? Answer will be, everybody, C is the correct answer, right? C is the correct answer. Got it? Yes, very good. C is the correct answer. C, beta, C. This is OH here. This is beta and this is beta. From beta positions, the hydrogen is eliminated, not from gamma position. Okay? Yes? Wait a minute. Oops, I forgot to do carbocation elimination. I'm so sorry, yaar. I forgot to do the rearrangement. Chalo. My bad. Let me do the rearrangement, right? I only taught you, I only forgot to do the rearrangement. Chalo, no worries. Let's do it here. This is OH. I just applied that concept. Chalo. Now, basically this dehydration with the help of concentrated H2SO4 or any dehydrating agent is done with the help of intermediate, that is carbocation. And I told you, wherever you have carbocation formation, always and always there is going to be rearrangement of the carbocation, right? So here, when this is eliminated, here you have the, wait a second, here you have, this is your carbocation, right? Now, carbocation rearrangement will occur. Now, basically what will happen, OH negative you have replaced from this side. We know that if you talk about this thing, this is a carbocation is 1, 2, 3. It is replaced by 3 things, right? So what we are going to do, right? If you talk about here also, it will have 1 hydrogen. Here also it will have 1 hydrogen only, right? Wait a minute. COH, OH negative, right? This is expansion. Okay, wait a minute, guys. This is a big process, so let me draw it here. So expansion, right? That will happen here. This is positive, right? And this is this kind of thing. This is a very good question. Okay, this is a very good question. This is positive. Now, I told you one concept, that whenever you have something like this, what will happen? Expansion will happen or contraction will happen. But firstly though you need to answer that expansion will happen or not. That is the first question here. So always remember that 6-membered ring is more stable as compared to 7-membered ring, because the same kind of question they have asked in pentane also, because this is a 6-membered ring. So that is why no expansion will happen. That is why no expansion will happen here. But if you see there is any 5-membered ring like that, right? Because this question can also be asked that if you see this kind of 5-membered ring you have, then in that case expansion will happen. In that case expansion will happen, because 6-membered ring is more stable as compared to 5 or 7-membered ring. 7-membered ring. So that is why in this case expansion will not occur. But what will happen to gain the more stability, right? What it will do, it will go towards the cyclic, that means the rearrangement will happen and this hydride will shift here. And what you will have the formation of, this is hydrogen will be linked here, this is positive. Now from the beta position, that means from here, right, this will be eliminated, and hence you will have hydrogen will be eliminated, and hence you will have the formation of double bond over here, and this is going to be the answer, right? Okay, yes, okay, chalo, got it? Ma'am, why can't, yeah, that's what I'm telling you, that D will be the answer. That basically first you have to look for two things here. If you have this kind of situation, right? Okay, if you have this kind of situation where it's not like this is the ring and if you have the carbocation over here, then nothing will happen, right? But if you have the ring and the carbocation is just one carbon away from the ring, then you have to think about the ring expansion, right? Okay, but in this case, as you can see here, this is a 6-membered ring. 6-membered ring is more stable as compared to 7-membered ring. That is why this will not get converted to 7-membered ring, right? Here, if you had, like I'm just taking an example, that if you had cyclopentane, in that case, ring expansion would have happened, and in that case, answer would be different, right? So here basically, that's why simple rearrangement will occur, not ring expansion or contraction, and hence answer is going to be D is the correct answer. Okay, yes, chalo. Now, oops. Wait a minute. Let me just see what is happening here. Which of the following is not a product? I have to solve this question again, guys. I got a little bit confused here, right? I need to solve this question on a separate page, or I'll just solve it here only. This is, okay, this is double bond. This is 1, 2, 3, 4. This is OH and this is CH3. Hai this is CH3. This is CH3. Okay, this is CH2 and this is CH3, right? Okay, so now if you talk about beta elimination, right, beta will be eliminated from this side, right? And here it will be, oh yaar, big mistake I have done. Acha, now let's talk about this thing. This was your alpha, this was the beta, this was the beta, and this was the beta. My mistake, right? This was the beta, this was the beta, this was the beta. 3 beta you will have, right? So basically they are telling that which, see, only one will be the major, other will be the minor only. They are saying that which will not be formed. This thing can be formed. That means this thing is possible. Possibility they are asking, na? Or this thing can be formed. That means this is also the possibility. Or this thing can be formed. That means this is also the possibility. Okay, then why not rearrangement? Let me just see that why rearrangement will not occur here, right? Let me just see that here. We have drawn this kind of structure, right? 1, 2, 3, right? That was your methyl and this was the positive. Wait a minute. This is 1, carbon is 1 degree, 2 degree, 3 degree, 3 degree carbocation. This is also 1, 2. Acha, okay. Okay, I'm so sorry. I missed. In my head, I was thinking about resonance, right? Okay, so guys, my mistake. This is not any resonance here. In my head, I was thinking about something else only, right? So basically, this is also 3 degree. This is also 3 degree. I have told you in rearrangement, right? That rearrangement will occur only when you have some more stability there, right? And there is no more stability, there is no resonance, there is no inductive effect, there is no back bonding, nothing like that is happening here. So rearrangement will not occur here. So yes, this is going to be that product which will not be formed. Not be formed. Right? Yes. So D is the correct answer. Okay? Yes. Chalo. My mistake. That's why you should always see the question very carefully. Right? Chalo. Now, next question on your screen is, in the following reaction, you have this thing, right? Now you have CH3. Firstly, let me draw it here. CH3. This is C triple bond CH. This is RHT, right? Red hot iron tube. Now, red hot iron tube at such a high temperature, that is 873 Kelvin, it is going to do aromatization. That means we know that if you had ethine, then benzene will be formed. But if you have mesitylene, if you have propyne, then which will be formed? This is C triple bond C. This is CH3, right? Here also what you will have, this is C triple bond C, right? This is CH3, this is CH3. And this is also C triple bond C, and this is going to be your CH3, 1, and this is also going to be CH3. So what will happen? Each pi bond will break and it will jump here, and you will have the formation of which thing? Mesitylene. That means double bond here, double bond here, double bond here, CH3, CH3 and CH3. Now they are asking you the number of sigma bonds present here. If you talk about the number of sigma bonds, it will be 3 bonds here, 3 bonds here, 3 bonds here. That means 6 bonds plus 1. This is going to have 4 bonds. Now, so let's draw 4 for each only. Right? This is 4, this is 4, this is 4. Carbon is going to have 3 bonds with hydrogen and 1 with this. 4, 4, 4. Then means 12. Right? Then what you will have? Then here it will be 1, 2, 3, 4, 5, 6. Right, so it should be 18. Let me check again. This is 1, 2, 3, 4, 5, 6. This is going to have 4 bonds and 1 more bond you will have, right? This bond hydrogen here, this hydrogen here, this hydrogen here. That means 18, 19, 20, 21, right? Plus 3 bonds with hydrogen. That means 21, right? Okay. And 21 bonds. Any sigma bond we are left with? I think we have taken up all the sigma bonds. So answer will be 21 is the correct answer. Okay. Chalo. Now next is the most suitable reagent for the following conversion is. The most suitable reagent from alkyne, how to prepare cis-alkene. How to prepare cis-alkene from alkyne. Cis-alkene from alkyne. That is prepared by which thing? That is prepared by everybody. Yes, that is prepared by which thing? That is prepared by Lindlar's catalyst. That is B is the correct answer. And if you want to prepare transalkene, then that will be done by Birch reduction. Right? Then answer would be A. Right? Okay. Chalo. Next question is the correct intermediate and the product. Now this is a very... Acha. How many of you remember what is the name of this reaction? How many of you remember what is the name of this reaction? In naming reactions, we have also done the name of this reaction. The name of this reaction I want to see in the comment section. Okay. So this is a very interesting question. Okay. This is CH3, C triple bond CH. Right. First thing is, ma'am, this is basically hydration of alkyne, which is done in presence of mercuric ions. Ouch. Right. Okay. So here it will be OH negative part is attached to less number of hydrogens, right? But ma'am, should we make Markovnikov addition here, or should we firstly make the carbocation? You should firstly make the carbocation here, right? Okay, because in case of dehydration, you always make that, right? And when you are adding something, right? So now basically it is following Markovnikov addition, that I agree, but here firstly make the carbocation, right? Then follow it. That would be better, right? So here if you add carbocation over here and this is negative, or the other possibility is negative here and carbocation here. We know that the positive here is more stable, right? That's why directly Markovnikov rule is applied, right? So that means this kind of carbocation will be formed here, right? Okay. That means to this positive OH negative will be attached. Now can I say this is enol form? Enol is always tautomerized to ketone. This is 1, 2 and 3. Now tautomerism means from 2 to 3 to 1 to 2, right? So this is CH3, this is C, this is CH2. So double bond is shifted here, that is double bond O, and hydrogen is shifted here, so it will be CH3. So answer will be ketone is formed, right? Okay, so they are asking you about the intermediate as well as that. So intermediate is CH3COH, C double bond O, and this is the ketone that is formed. So answer will be C is the correct answer, okay? C is the correct answer, right? Oh, question was not visible. Chalo, theek hai. Chalo, now that I told you, I'll just take care of that, whether the next questions will be visible or not, right? Chalo ji. Now, is this now visible to you? Now is it visible? Okay, if that is not visible, then I'll just rewrite it, right? So this is basically, this is HC triple bond CH, and here you are using NaNH2, right, in presence of liquid ammonia, right? And here you are using CH3. I'll just give you a hint of this. This is a step-up reaction, okay? Again, here you have made X here. From X, you have the formation of Y. This is NaNH2. This is liquid ammonia, right? And this is CH3CH2Br. Now tell me, what is the answer here? Yes. Okay, I think now it's completely visible to you guys, right? Okay, chal. I'll take care of that in the next class. So you have CH triple bond. This is NaNH2. So now here what you will do, right? What you're going to do. First is CH triple bond, right? Okay, so this is HC triple bond CH. From here, you are adding NaNH2. So NaNH2 this is Na positive. That is why what will happen? It will donate the proton. You will have the formation of Na here, right? After you are adding CH3, CH2Br, Na and Br are going to leave from this side, and here you will have the attachment of the CH2, CH3. So here it will be CH2, CH3. Same thing we are going to do again. So this is basically X. This is X. Okay. Again, with this proton will be replaced by Na. So it will be C triple bond C, CH2, CH3. Here this proton is replaced by the Na. After this, again you have the addition of CH2, CH3 over here. Right? Now tell me, this is Y. This is Y. Now tell me which is the correct answer. First is the 1-butene is formed. Okay, that is right. In second, you have 3-hexene is formed. 1-butene and 3-hexene are only in case of first. So answer is A is the correct answer. Okay, A is the correct answer. Next, you have, which of the following reagents will be able to distinguish between 1-butene and 2-butene? So it's a very, very interesting thing. 1, 2, 3, 4. Right, 1-butene, and you have 1, 2, 3, 4 this butene. The difference here is This is terminal alkyne. And to understand one thing, that terminal alkyne, okay, it is going to replace, right, only one thing will work here, that is NaNH2. Here we have seen the reactions, right? So NaNH2 was actually replacing the terminal hydrogen of that alkyne with Na, right? That is why NaNH2 is going to show the reaction with terminal alkyne, not non-terminal alkyne. So answer will be A is the correct answer, okay? Yes, because terminal alkynes are acidic in nature. Predict the product C obtained with the following reaction of butane 1. So here they are talking about that predict the product C obtained in the following reaction of butane 1. Okay. Predict the product C obtained over here. So here what you have HCl, after that you have HI. Okay. So here what you will do, this is CH2, CH2, C, triple bond CH, and this is HCl. CH and this is HCl. When you are adding HCl here, what will happen? This is triple bond. So firstly what will happen? Negative and positive. Negative part is going to get attached to less number of hydrogens. That means here what will happen? This pi bond will break here, right? And negative part is going to attach to less number of hydrogens. That means Cl here, and this will be CH2, right? Then you are again adding HI here. This is negative, this is positive. Negative part is going to attach to less number of hydrogens. That means here. And here positive hydrogens will be attached. So answer will be CH, this should be CH3, this should be CH3, right? Okay. So it will be CH3, CH2, C, CH3, CH2, C, I, this one more bond will break definitely, right? Okay. Single bond CH3. So answer will be C is the correct answer. Okay. C is the correct answer, right? Okay, so this is going to be the correct answer. Next we have the oxidation of benzene by V2O5 in the presence of air produces. Oxidation of benzene by V2O5 in the presence of air produces. Now, this is a very, very interesting reaction. Let me see how many of you remember this, because it's a new reaction, right? Okay. Now, basically, guys, it is going to give you a anhydride, that is maleic anhydride. Let me show you the reaction as well. So, this is benzene in presence of oxygen, in presence of V2O5. Highly oxidizing it is. So, what it is going to give you? It is going to give you maleic anhydride. Mechanism is not in your syllabus. Just remember, when this is anhydride, C double bond O, O, C double bond O. Over here, just add CH and CH, right? Okay. Understood? That is going to be the answer for this. Okay, that is maleic anhydride. Next, you have the enthalpy of hydrogenation of these compounds will be in the order as enthalpy of hydrogenation, guys. Enthalpy of hydrogenation, guys. Basically, enthalpy of hydrogenation is, it is opposite of the stability of alkenes, right? Firstly, write the stability of alkenes. Firstly, write the stability of alkenes. Okay, if you know the stability of alkenes, then you will also know opposite order will be for enthalpy of hydrogenation, because more stable, more is the stable is the alkene, right? So in that way, the enthalpy will be required, right? So if we talk about the stability of the alkenes, this is benzene. Resonance is very strong here. So first we'll have the maximum stability. Then this is going to show conjugation, right? This will be here, this will be here. So double bond, single bond, double bond, single bond, double bond. It is not resonance, but it is showing conjugation, right? Third, it is not showing any conjugation, double bond, single bond, single bond, double bond, single bond, single bond, double bond. So there is no resonance, so it will be least stable, right? So the enthalpy of hydrogenation will be opposite of that, right? Okay, so here it will be 3, 2, 1. 3 is maximum, then 2, then 1. So answer will be A is the correct answer, right? Beta, this is stability of alkene is opposite to hydrogenation. Where is EOH? It is opposite, right? It is opposite, inversely proportional to that, right? So if this is the order of alkene stability, opposite is the order of enthalpy of hydrogenation, right? Okay, understood? Yes. Next is which of the following is most reactive towards electrophilic attack? Electrophilic attack, that means maximum electron density it should have. If you talk about the effects here, so if you talk about this, there is no resonance, so definitely it is not going to have the maximum electron density, right? Here it is showing minus I and minus M effect, so it is taking out the electron density, so this is also ruled out. If you talk about this and this, here it is also showing minus I and plus M effect. This is also showing minus I and plus M effect. But in case of halogens, minus I effect is dominating. But in case of OH, other things, minus I is not dominating, plus M is dominating. So overall it is electron donating group. Overall it is deactivating. This is activating group. So this is also ruled out. Maximum electron density will be on B. That is phenol is the correct answer. Okay. Very fast reaction will occur on phenol, right? Okay, got it? Chalo. Next you have using anhydrous Cl3 as catalyst, which one of the following reaction produces ethyl benzene? Acha, ethyl benzene they are talking about. Using anhydrous Cl3 as catalyst, which one of the following reaction produces ethyl benzene? Ethyl benzene, beta. Now, let us talk about this. Ethyl benzene means it should produce this thing, CH2CH3, right? We know that they are talking about Friedel-Crafts reaction that will be produced if you have benzene on benzene. If you have CH3CH2Cl and then anhydrous this, that means that is only possible in case of A. So CH3CH2Cl plus C6H5 is going to be the correct answer. That is A is the correct answer. Very good, Mohammed. Welcome to the class. Welcome to the class. Okay. Now, wait a minute. Let me just rewrite it. This is X here and this is Mg. This is ether. Okay. This is ether and this is hydrolysis. Now, beta, I told you, see, first thing is, this is C6H5, right? That means benzene. Then you have CH2, then you have Br. Whenever it reacts with Mg in presence of ether, it is going to replace and convert this into MgBr. That means Grignard reagent. Grignard reagent on hydrolysis is going to remove this and become CH3. So that means toluene will be formed here, right? That means toluene will be formed here, right? That means toluene will be formed here and this is toluene, that is C6H5CH3. So answer is going to be D is the correct answer. Okay, D is the correct answer. Chalo shabash beta. Now next question is C7H8 in presence of 3Cl2 and heat. It is going to give you A. This is again Br2 and Fe. It is going to give you B. Again, it is zinc and HCl. It is going to give you C. Right? Now, beta, see the options here. Okay, see the options here. It is toluene, 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 toluene. That means it is, they are talking about a cyclic ring. Right? That means they are talking about this thing. Right? That means in the first option, we know that this is C6H6, C6H6, right? But here they are talking about C7H8. If you Subtract C6H6 from here, you will get CH2, right? Okay, CH2 you will get. CH2, na, one hydrogen will also be replaced. That means here you will have toluene. That means the starting product will be toluene. Here you have 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens you have in toluene, right? So here it is C7H8. This to we know. After adding, now I'll just draw the chain here. After adding, most of the reactions that we are going to do now is going to be chain reactions only, right? So here you will have chain reaction means that have a sequence, okay? So this is 3Cl2 and heat. 3Cl2 means here you are going to replace this, right? Heat means free radical. Substitution will happen here, right? So here what will occur? This will be replaced by CCl3 because you have three, you have 3 moles. That means 3 hydrogens easily can be substituted here, right? Now this is A. Now they are telling you, they are asking you for this product, that is C. After this you are adding Br2 and Fe. Br2 Fe means it is going to give you Br positive electrophile. Now guys, we know that this is ortho-para directing. This is ortho-para directing. But CCl3, 3 chlorine electron withdrawing things are attached here. That means here this overall effect of this group will be minus M effect. So it is going to be meta directing, right? So that is why it is going to get replaced on the meta position. This is also a very nice question, okay? This is also going to get replaced on the meta position, right? After that you are adding zinc HCl here. Zinc HCl is used for reduction. So here what will happen? This will be again reduced to CH3Br. That means meta-bromotoluene will be formed here. So answer will be A is the correct answer, right? Okay. Welcome Ragvi, welcome. So A is going to be the correct answer, okay? Chalo. Why para bhai? CCl3. Bitta. You need to delete this. हाँ, ठीक है? चलो. Next question. Now, Now, next is which of the following compounds is aromatic in nature? If you talk about the aromaticity of the compounds here, right? So if you talk about this, it has 2 pi electrons. This is having 4 pi electrons. This is not at all planar, so it will be non-aromatic. This is definitely not aromatic because no complete conjugation is present here. So this is anti-aromatic because of 4n pi electrons. This is 4n plus 2 pi electrons because it is having, if you put n is equals to 0, you will have 2 only. So it is aromatic. So answer will be A is the correct answer. Okay, A is the correct answer. Next you have which of the following chemical system is non-aromatic in nature? So guys, it is clearly visible, right? It is clearly visible. Let's talk about this thing. Cyclic PCC is followed, cyclic planar conjugated, complete conjugation is there, 1, 2, 3, 4, 5, 6 pi electrons, so it is aromatic. Non-aromatic, na, they are asking you. This is also aromatic because one aromatic ring is attached here. This is so definitely aromatic. Here you don't have complete conjugation, so this is going to be non-aromatic in nature, right? Moreover, this is not planar, right? So answer will be A is the correct answer. Next is what will be the product through SN1? Now, beta, we are going to talk about questions, right? Okay, yes, A is not conjugate, so A is going to be the correct answer. Which will be the product through SN1 reactions? Okay, so now SN1 and SN2, SN1 is a reaction where you have the formation of carbocation, right? Okay, just remember that thing. Here if carbocation is formed, right? Which carbocation will be formed? Over here you will have positive, which is a 2-degree carbocation. So rearrangement will not occur because 3 degree I can't see anywhere. So definitely it is going to replace this X with OH. So answer will be CH3, CHOH, CH2, CH2, CH3. So A is going to be the correct answer, right? Okay. Chalo. Next is, now this is very, very interesting. This was the thing that I was talking about, right? I told you, na, there is one question where there is a rearrangement happening. This is that question. Very, very important question this is, right? So SN1 means carbocation is formed here. If you lose this X here, it will be the formation of CH2 positive. Now I told you that whenever outside the ring you have a carbon having positive there, so you will have expansion here. So expansion, how you will do? This is 1, this is 2, this is 3. Expansion will be done like this, that just break the bond of 1 and 2. Okay, how you're going to do the expansion? This is 1, 2, 3. This is CH2. Here what we are going to do? Break the bond of 2 and 3, attach 1 and 3. Break the bond of 2 and 3, attach 1 and 3. So 1 and 3 will be attached here. And here, hence, this positive is shifted to this 2. Right? So this will be the carbocation. If you see this, it is going to be like this. Okay? Okay, it is going to be like this. After adding OH negative, it will become like this. Okay, so answer will be A is the correct answer. Okay, right? Okay. Really, all right answers are in A options. Don't apply these guessworks in your exam. Okay. Elimination reaction of 2-bromopentane to form pent-2-ene is 2-bromopentane. You have 1, 2, 3, 4, 5. 2-bromopentane, right? To form pent-2-ene. Pent-2-ene means 1, 2, 3, 4, 5. Pent-2-ene means this thing. Now you just need to understand one thing here. Here we are basically forming more highly substituted base, more highly substituted alkene. That is according to the Sedgwick rule. So this is so true. And this is D-halo, and here there will be hydrogen which will be substituted dehydrohalogenation. That is also true. And this is alpha, this is beta. So this is basically beta elimination. From beta position you are taking out the hydrogens. So here this is also eliminated. So that means A, B and C. A, B, C. Now A is not the correct answer, right? A, B, C. A, B, C. So answer is D is the correct answer here, right? Okay, chalo ji. Next question is, which of the following reaction is appropriate for converting acetamide to methanamide? So what is acetamide? Acetamide is this thing. Acetamide, guys, this is C double bond O NH2, right? It is converted to methanamine. That means CH3NH2. Guys, very simple. This thing is eliminated. Very, very important, famous reaction. What is the name of that reaction? Very, very famous reaction. What is the name of that reaction? Name of that reaction is Ames only. That is Hoffman bromamide degradation reaction. That is A becomes the correct answer. Okay. A will become the correct answer, right? Okay, chalo. Next is method by which aniline, okay, method by which aniline cannot be prepared is. Method by which aniline cannot be prepared is. Guys, method by which aniline cannot be prepared. Anybody in the comment section? Right? Okay. Very nice. Also, I am very, very happy that you are liking it. So, method by which aniline cannot be prepared. Hydrolysis of phenyl isocyanide with acidic solution. See, isocyanide means this thing, right? Definitely aniline can be prepared from this thing, right? Okay. Hydrolysis of phenyl isocyanide NC, right? Okay. Then you have degradation of benzamide, with bromine in alkaline solution. Reduction of nitrobenzene with H2, potassium salt. Okay. See, degradation of benzamide. If you have benzamide, right? Okay, benzamide, you degrade it with bromine solution. Definitely, that can also form. This is the Hoffman bromamide degradation only they are talking about. Also possible, also possible. Reduction of nitrobenzene. If you reduce nitrobenzene, right, that is also possible to convert it into aniline, NH2, possible. Potassium salt of phthalimide. They are saying that potassium salt of phthalimide, this is phthalimide, right? Here, very, very important thing, followed by hydrolysis with this. See, chlorobenzene, the important, this is basically Gabriel phthalimide reaction they are talking about. In Gabriel phthalimide reaction, we have, firstly, so we add KOH, this is replaced by K. Then we add RX. So they are saying that this RX is nothing but this is chlorobenzene. So this, the condition, the demerit of this Gabriel phthalimide reaction is that this R cannot be aromatic in nature. If this R is aromatic, then it will have a double bond character, so it will be difficult to break this bond. That is why in Gabriel phthalimide reaction, we can never take R as aromatic, but here they have taken R as benzene, that is aromatic in nature. That is why this reaction is not possible, right? Okay, so answer will be D is the correct answer. Okay. Next question, guys. On your screen, we have the correct. Next question, guys. The correct order of basic strength of methyl substituted amines in aqueous solution. Okay. What we are talking about? The correct order of basic strength of methyl substituted amines in the aqueous solution. They are not talking about gaseous phase, they are talking about aqueous phase. So in aqueous phase, you have, if you have methyl as the alkyl group, this is 2,1,3. If you have ethyl as the group, that it will be 2,3,1. Here you have methyl, so answer will be 2 degree, then 1 degree, then 3 degree. This is 2 degree, this is 1 degree, and this is 3 degree. So answer will be A is the correct answer, right? Okay. Very good. Not revise every topic. Yes, very good. Very nice, Pratibha, that you are able to revise all the topics, right? So keep motivating us also with your shares, with your comments, with your likes, so that we can also get motivated and we can also bring more such sessions for you. Okay. So yes, tomorrow also Gopika ma'am and Baswa sir is going to take up your bio class. That is going to be very, very interesting, right? So we also want to do the same for physics, chemistry as well. But for that, we need your support, right? Okay. Thank you, Nandu. Thank you. The correct increasing order of basic strength. Now you tell me what is the correct increasing order of basic strength. See, basic strength, always remember that basic strength is directly proportional to electron donating group, inversely to electron withdrawing. It depends on the availability of lone pairs. It depends on the availability of lone pairs. Now, if you see this here, if you see this thing here, this is electron withdrawing, this is electron donating. So electron donating will increase the basicity. So maximum will be for 3. Then you will have which has no effect. Then minimum will be for electron withdrawing, that is 2. So answer will be 312. 312. 312 is, that means A is going to be the correct answer. Okay, A is going to be the correct answer. Right? Okay, chalo. Arey yaar, what is their problem? Correct increasing order of basic strength. 3. Oi, I'm so sorry, yaar. Why I'm so much in hurry? Beta, 312. This is opposite, yaar. This is opposite. This is 213. 312 is 312. 3 is maximum. 3 is maximum here. Then 1, then 2. It is C. Guys, biggest example. Solve the answer, still marked it wrong, right? Okay, in hurry, don't answer anything in hurry, right? Okay, I am just trying to save your time. but I think I should relax. Okay, so answer is 3, 1, then 2. Okay, chalo. Next is, which of the following amine will give the carbylamine test? Now, carbylamine test is only given by primary amines. Primary amines. Can you see any primary amine here? 2-degree amine. This is 3-degree amine. This is primary amine. This is also 2-degree amine. So answer will be D. That is the primary amine. Right? So only primary amine are going to give you carbylamine or isocyanide test. Nitration of aniline of strong acidic medium also give M-nitroaniline. Now they are saying that if you talk about the nitration of aniline, this is a very, very important question. I don't know, I have a gut feeling that they are going to ask you the same topic regarding nitration of aniline, because it is a very interesting thing that it is going to give you ortho, meta and para. It is supposed to only give ortho and para, but it is also give you meta, that is 47%, right? Meta product it is giving you. Right? Only 2% of this is it is giving you, 50%, 51% of para it is giving you. Right? Now, interesting thing is why it is giving you this thing, because in the nitrating mixture, you have concentrated HNO3, concentrated H2SO4, which is very acidic, and this is a base. That is why what will happen? A base is a proton acceptor. It will accept the proton and become anilinium ion. And anilinium ion is meta-directing. Anilinium ion is meta-directing. Then what will happen in this case? This meta-directing substitute, let us see. In spite of substitute, nitro group always goes to only this. That is not true at all. In electrophilic substitution reaction, amino group is meta. Definitely not. In acidic medium, aniline is present as anilinium. Yes, absence of substitute nitro group always goes to this. No. In acidic medium, strong acidic, aniline is present as anilinium ion. So C is going to be the correct reasoning for that. They can ask you this in form of assertion reasoning to make this question even more interesting. Right? Okay? Chalo. Right? Okay. Now, next is identify the product D. Okay? You have to identify the product D here. Everybody try to solve it. Shabash beta, try to solve this question, try to solve this question yourself. Chalo. Identify the product D. So when you're going to add SOCl2, this is C, double bond O, OH, this is Br. This SOCl2 means it is going to replace this OH with Cl. Then adding NH3, it is going to replace this Cl with NH2. Then after adding NaOH and Br, we know that this is Hofmann bromamide degradation. This will be eliminated, and hence this will be eliminated, and hence you will have only NH2 over here. Right? CO will be eliminated. That means you will have ortho meta. That means this thing you will have. Right? So this is the answer that you will get. So answer will be C is the correct answer. Okay? Understood? Next is the reaction sequence product C. Product C. So if we talk about the first one, we know that this is diazotization, NaNO2 HCl, or they can also give you HNO2, they can also give you NOCl at 0 to 5 degrees Celsius. It is going to give you disonium salt here, that is N2Cl, positive, negative. Then CuCN, you add CuCN, this will be replaced by Cn. Then this B is formed, A we have done, B we have done. Then after that you do the reduction. Reduction means basically you have 3 bonds here, right? 2 pi bonds will break, right? And this will be H2 will be added. H2 will be added here. H2 will be added here. So it will be benzynamine, benzoic acid, benzaldehyde, benzonitrile, CN. Benzonitrile. See, they are asking you, na? Benzaldehyde. Benzoic acid. Benzylamine. Yes. Benzylamine is formed. Benzyl, this group is called benzyl. Okay. Benzylamine is formed. That means D is the correct answer. Okay. Arey beta, this is not benzoic acid, yaar. Huh? Benzoic acid. Benzylamine. Chalo, next question. In the following reaction, this is the reaction they have given us. They are asking which is the A reagent that you can use. What we can see here, NO2 is intact, Br is also intact. Basically, we need to eliminate this N2Cl. We need to eliminate N2Cl here, right? Eliminate N2Cl. So whenever you have disonium salt, right? If you want to eliminate N2Cl, you can use, out of this, you can use H3PO2 and water, right? So answer will be B. Or they can also ask you to use ethanol. If you use ethanol also, then you will get directly, you will eliminate this N2Cl with hydrogen only, right? Okay, so answer will be B is the correct answer, right? Okay, chalo, next is reaction by which benzaldehyde cannot be prepared. Okay. Can you tell me name of this reaction, guys? Name of this reaction? Name of, acha, theek hai. Okay. Name of this reaction, all these are naming reactions. Name of this reaction. Name of this reaction. All these are naming reaction, guys. This is Gatterman-Koch reaction. This also they can ask you. Gatterman-Koch reaction. This is Itard's reaction. From toluene, you are preparing benzaldehyde. This is Rosenmund reaction. Rosenmund reaction. Right? Okay. Acha. This reagent, I know. This reagent is basically Clemenzin. Clemenzin reagent. Clemenzin reagent. Right? But this is not used for converting benzoic acid to benzaldehyde. Right? This Clemenzin is used to convert ketonic or aldehydic carbonyl to reduce that C double bond O to CH2. Right? So this is the correct answer, which cannot be prepared. Benzaldehyde cannot be prepared with this particular thing. Right? Okay. Very good, very good, very good. Next beta we have, next question is, predict the products here. You have to predict the products here. Acha. Firstly, though, you have to identify. See, the biggest problem is students are not able to identify which reaction they are asking you, right? Okay, for that, revisions, practice are important, right? Okay, that's why I have come up with these kind of questions so that you're able to understand like what they are asking you. What is this 50% QH? Either it can be alcohol or aldol or canizaro. I'm giving you a hint. Canizaro or aldol. Now it does not have alpha hydrogen, which is sp3. Alpha hydrogen it does not have. That is why it will be canizaro. Benzaldehyde will show canizaro reaction. In canizaro reaction, one product is disproportionation reaction. It is one product is forming the same number of alcohol, other is forming the same number of carboxylic salt. Right? This is not same number. This is CH2CO. This is C. This is one carbon after the ring. This is two carbon like outside the ring. Right? So this is not the correct answer. This is the same number of carbon alcohol. This is the same number of acid. But here, this is also replacing this Cl with OH. Right? Okay. So that is also not the correct answer. If you talk about this, here it is getting converted to CH2OH. But here it is CO. So that is sorted. That with that aldehyde or ketone, right, one is converted to alcohol and other to carboxylic acid salt with same number of carbon. And this is at ortho-meta. This is also at ortho-meta position. That means C will be the correct answer. Okay, C will be the correct answer here. Right? Okay, C will be the correct answer. Got it? Yes, beta. Acha. Next question is, following compounds are given, which of the above compound on being warmed with iodine solution will give iodoform test? Again, a very, very important test, iodoform test, right? Very, very important test. Now, I have told you that in iodoform test, what you need to have, it should give CH3, it should have this kind of group, or if it is an alcohol, it should be having this kind of group. Here you are talking about alcohol, so it should be CH3CHOH. Okay, this is CH3CHOH. It can give us. This is CH3OH, it will not give us. This is CH3CO, it will give us. This is CH3C double bond O. This is CH3CH, basically, yes. This will also give us the iodoform test because it will be CH3CHOH. Hai na? So it will be like this only. Right? Okay, same kind of compound it is forming. So answer will be 1, 3 and 2. 1, 3, 1, 2 and 3. 1, 2 and 3, that means C will be the correct answer. Okay? C will be the correct answer. Okay, chalo. Now next is the product is. Now you need to tell me that this is a very, very interesting question. Okay? Very interesting question. The product A you need to tell me, right? Firstly, A is getting reduced, B is formed, then you have CH3. This can be either rimer-temer or carbylamine because both are having the same reagents. Something is getting formed here, and here you have N-methylaniline. Okay. In aniline, right? N-methyl, that means one hydrogen is getting substituted with CH3. Acha. After reduction, you are getting this. We know that if you have aniline, nitrogen, so definitely there is carbylamine only, because if you have nitrogen, aniline, that means some this kind of thing is happening here, right? Some carbylamine reaction that belongs to amines, that belongs to anilines. But rimer-temer reaction, if they would have given us hint of phenols, right, then we would have thought about rimer-temer reaction. So that means it is definitely carbylamine reaction. Carbylamine reaction means we know that here you will have the formation of NC. So that means if here by reduction I am forming this thing, that means here this C would have been N triple bond C, right? Okay. 3, 4. Only then what you will have, wait a minute. If you talk about this isocyanide C here, this A, what should be formed? That B, wait a minute. If you're talking about trichlorochloromethane, that will not be the correct answer. If you have nitrobenzene, nitrobenzene, wait a minute guys, I'm just doing hit and trial here, okay? So nitrobenzene, you just have to also see the options here. If I say nitrobenzene is having the maximum probability here, nitrobenzene, I know after reduction it will form aniline. Aniline after carbylamine, it will form N triple bond C, and after the reduction further it will form N-methyl this, right? So answer should be nitrobenzene, right? Nitrobenzene on reduction, aniline after this carbylamine reaction, it will convert this NH2 to N triple bond C, right? Primary amine, it is getting converted to N triple bond C. Very pungent smell. After the reduction, it is this. So answer will be C is the correct answer. Okay? Okay, ji, chalo. Now, next is the major organic product. Now, these reactions are very interesting. Okay? The major product formed in the following reaction. Now, guys, there is one reaction which is that if you have C double bond O, this is R dash, and here if you have NH2Z, then water will be eliminated, and here you will have the formation of NZ here. Same concept we will apply here. This is double bond O and this is CH2 NH2. So what we will do, this will be double bond and this is methyl. This oxygen is replaced by this nitrogen and CH3, right? Water is replaced, oxygen is replaced, eliminated. You have NCH3. After that, you are doing the reduction. Reduction means you are adding water into it, right? Okay, you are adding water into it. You are adding hydrogens into it. Pi bond will break. Pi bond will break, and hence you will have the formation of hydrogen and hydrogen here as well, right? NHCH3. So answer will be definitely not OH here, not OH here. This will also not be the answer. This is, so with oxygen they have attached this, so this will also not be the answer. This is CH3, CH3. This is C. This is CH3. This is NHCH3. So answer will be B is the correct answer. Okay? B is the correct answer. Okay? Done? Chalo. Done, beta. So B is going to be the correct answer. Just remember this, that here H2 and oxygen will be eliminated. Double bond will be attached. After LiAlH4, reduction will happen. That means pi bond will break and hydrogen will be added here. Firstly, eliminate it. Then after that, it will be easy for you to identify the correct answer. Okay. Acha. Next is identify compound X in the sequence of reaction. Now this is basically Cl2H mu. So it's a very like repetitive question, right? Okay, very simple. So basically here what you will have, this is CHCl2 will be the intermediate. After hydrolysis, this will be converted into CHO, right? So answer will be CHCl2, right? Answer C is going to be the correct answer. Okay, chalo. Next is in the following sequence, you have the following sequence. I think this is your last question only. Now still we have still questions we have. Acha. In the following sequence, end product C. End product C. Okay. So simple. This is CH3Br, right? Okay. This is CH3Br, beta. So here what you're going to do, this is CH3Br, right? CH3Br in presence of KCN, Br will be replaced by Cn. After the hydrolysis, we know that this is C triple bond N. After the hydrolysis, what will happen, right? After the hydrolysis, this will be replaced by double bond O. Basically, this will happen, KCN. This is C double bond, wait a minute, C triple bond N. After the hydrolysis, it will be CH, and this is double bond O. Then after LiAlH4 ether, right? Hydrolysis means this thing will happen here. 2 pi bonds will break, right? Okay, 2 pi bonds will break, right? After the hydrolysis, 2 pi bonds will break. This is H. If I give it H and H, and if I give it O, just give me a second. If I break these double bonds, C triple bond N, 2 pi bonds I'll break. Then this will be H2. This will be H2. And after the hydrolysis, this is converted into double bond O. Just let me see, beta. Just give me a second. After the hydrolysis, LiAlH4. है ना? After the LiAlH4, that means reduction, it will be converted to CH2OH. CH2OH. Okay, so that is the possibility that we are getting. That means ethyl alcohol will be formed. Okay, so answer will be D is the correct answer. Okay, understood? So basically hydrolysis you have to see with C triple bond N, right? That with C triple bond N, what will happen? Firstly, CH2 and this CH2. Then after the hydrolysis further, this will be converted to double bond O, right? So you can just understand this by, this is C triple bond N. I'll give you a simple method. This is H2O, right? So 2 pi bonds will break, 2 hydrogens will be here, and this will be double bond O. Okay, so this is how you are going to have the formation of double bond over there, right? Okay, next is consider the following reaction, the product Z that is formed. Okay, if you talk about this thing here, this is phenol. Phenol, we have a zinc dust, that means this is converted to benzene with zinc dust. Then again we have CH3Cl, they are asking you Z, that means you have to answer them this thing. CH3Cl, that means CH3 will be attached here, right? After that you are doing alkaline KMNO4, that means oxidation you are doing, so answer will be COOH. So that means Z will be benzoic acid, right? So basically, yeah, these are like sequence reactions from A to B, B to C, C to D. And my idea is that in NEET 2025, they will ask you these kind of questions more instead of just one reaction. They will ask you 3-4 reactions in just one question, right? Because this is a sequence that they follow in JEE Mains. So to level up your NEET also, they will not ask you something out of syllabus, but in one question only they will ask you a lot of questions. Okay, so here you need to have three simple reactions, you need to have knowledge about them, and you will have the answer, right? Okay, next is acidic cleavage of HI gives, so acidic cleavage, I am saying anisole on cleavage. Anisole means OCH3. Now we know that the bond, this cannot break because here it will have partial double bond also. So this bond will break here. This bond will break here. So answer will be phenol, right? This bond will break here. Answer will be phenol and CH3I. So A will be the correct answer here, right? Okay. Okay, Ji. Acha, next is the reaction can be classified as, this reaction is given to us. This is the reaction. Here, beta, see, they have given you NaH, right? Na is positive, H is negative here. So what will happen? That is why, see, they are just asking you the name here. Na is replaced by this H, so it will be ONA. So that is alkoxide. That is alkoxide. And this is MEI. This is alkyl halide. They both are forming ether. So when you have the formation of ether from alkoxide and alkyl halide, what is that called? What is that called? That is called as, very good, that is called as Williamson synthesis ether reaction, right? That is C is the correct answer. Okay. Okay, beta, done. So yes, we have completed the most important questions of organic chemistry that we have completed. Now, day 3, we are going to do physical chemistry questions, and I really hope that you will enjoy it and you are going to love it, because we are going to solve a lot of questions, right? But, right, the questions are very selected, like you today also saw that, like mostly I have touched all the concepts here, right? So that will really help you. Even in physical chemistry, we are going to take up questions from full physical chemistry, right? The important topics we are going to pick, and we are going to see that what kind of questions are asked, right? And you will see that the same paper you will see in NEET 2025, right? The same questions are repeated, guys. The same questions are repeated again. They will not make some new reaction, right, for NEET 2025. Right? They will ask you the same questions again and again and again and again. It's just the way of asking it is different. And I'll tell you, students do previous year question, but they don't remember it, right? They don't, if the same previous year question is asked in a little language is changed, or, you know, they have changed a little bit about that question, students will mark it wrong, right? Okay, so that's what I'm telling you, that don't ignore previous year questions and do the questions that are also related to previous year questions. For that, I have already given you a PDF, right? PDF you will see over here, right? Over here, beta, you will see the PDF, right? Let me give you the PDF. inorganic chemistry. Day 1 inorganic chemistry, that you will see the PDF over here. Wait a minute. Wait a minute. Huh. Okay, and this is the treasure box that you have, right? So in this treasure box, basically everything I have linked up here, right? Physics, chemistry, everything beta I have linked up here, right? So here you will find the YouTube sessions as well as the links to the notes. Everything is provided here, and I think that also here, not think, actually I have given you some 50 questions, I think, because of some mistake, right? The wrong PDF is uploaded here, right? So the PDF will be uploaded here. The PDF consists of around 50 questions, right? So these 50 questions you need to solve, right? Okay, that is your task, that is your homework. And yes, that will be provided to you. You can check this link, this particular video tomorrow as well, right? In that way, just click on that and you will get your PDF where you need to solve the questions, okay? Right? Okay. Yeah, Christmas with chemistry on Wednesday, right? Okay, now guys, here what we have, and yeah, I'm going to take up the class at 5 p.m. right? That works, right? I'm going to take up class at 5 p.m. not at 6 p.m. Reason being, here I also have some event in my, some function in my house, so I need to go there as well, right? But still I thought that why to miss the class, right? Okay, so this is guys our batch fast track batch that is going on. So in this batch basically we have three things, that is prime, combo and pro. Prime means you will get the live session, online test, online pedagogy. You need to watch something in detail. You can also watch that. And the live classes are going on from 5 to 10 p.m. Students are already doing the revision. Their syllabus is completed in DNA batch. They are already doing the revision, right? And if you want to get all India test series as well, then you can enroll for combo batch where you will have a home delivered test series at your house only, right? So you can practice them at any time of the day. Moreover, the video solutions will be provided to you. Next is if you want to have crash course books, right? Hard copy of crash course books and the doubt app, right? 24/7 doubt app, then you can go for pro batch, right? Okay, so these are the three batches that you will have, right? So according to your need, you can go for any of this batch, right? And guys, that thing will not be completed on YouTube. That is only there in the batch and for those students. So I would really advise you to go for that and yes, start your revision there. Okay guys, then bye bye, take care, see you all in the next class. Bye bye.